What's that?
Eating chips off the ground gone wrong.
You gotta admit, this floor is disgusting. No matter where you ate it from, it had to have picked up a little bit of something.
It had,
And it was longer than 5 seconds.
yeah, like.
That was on the ground for like a solid 20 seconds.
And you ate it.
It's not like the dirt that I ate.
I mean,
Like 5 seconds.
Right.
We all had to die.
I eat school lunch.
I hope that you guys just don't die.
They're immune from the COVID.
If y'all die,
Wait, does that mean you get to sue the school? With that?
if you die,
Or my parents?
Well, it was kind of.
no,
You
you made the choice.
Yeah,
to eat
you
it.
did.
No,
No, nobody
I was
told
worried.
you.
In
There
fact,
was
we
no
will
forbidden.
probably all stand up and say we were telling them not to do it.
Yeah.
No, I got you, Aiden. I'll say you were peer
So-
pressure.
Yeah, I was peer pressure.
All
No,
right.
you were peer pressure by possible.
Too bad I don't have it in a recording. But I have this conversation in recording.
Well, they know what happened.
There you go.
All right. Let's get to our review, okay? Like I said, the quiz is a take-home. For people who are DL or TDL, I put a note out there, and I'm saying this for the recording, okay, guys? So, for people who are DL or TDL, I told you, you have to email me, and I will send you the quiz, okay? I'm not just gonna send them out willy-nilly. Okay, now, there are two types of equations that we've talked about, okay? Logarithmic and exponential. And they're kind of no-brainers, right? That's what the first thing's talking about. If it's logarithmic, guess what it says in the equation? It'll literally say log somewhere, right? If it's logarithmic, it's going to say log. Now, there's two types. It could be log equals log, right? In that case, we do what? We drop off the logs. Or it could be log equals a number. And if it's log equals a number, what do we say we did? We write it as a exponent. They call it exponentiate. We write it as an exponent. And of course, you use the base from the logarithm. That's the key. Okay, that's the key. You start from the base of the logarithm. That becomes the base of your exponent. All right? The other type is exponential. And we said, what is the key for representing an exponential function or equation? You got to have what in what position to be exponential? It's got to have a variable somewhere in that exponent spot. Okay? Remember, with all those problems we were just finding a minute ago, we were actually saying, where's that exponent? It always had a variable in it, and then we, of course, locate it in its base. Now, if we can write both sides that have the same base. That was the first method that we used. But that method kind of becomes obsolete because once people learn this second method, they just like it better. Because one reason, mainly, it always works. You see, you can't always make them have the same base, but you can always isolate that exponent and rewrite it as a what? What were we doing last night? Rewriting it as a logarithm. So that's the way that people usually go. In fact, there's one problem in here that we're going to do where you could actually do it, either method. And I want to show you it, okay? So let's go. I'm going to probably skip one because we've lost a little bit of time with Jace and Aiden being disgusting and eating chips off the floor.
That didn't happen. That didn't happen.
It did happen.
It did happen.
It
did not happen.
We're trying to convince the video, or
Our said she didn't drop it.
It did not happen.
Yeah.
so you're blaming that on Kayla.
Yeah, pretty much.
I mean, you would have had to waste time to clean it up anyway.
She offered no one shit.
Now
Yeah.
I would have
We
been,
don't
Yeah.
clean
I would have been absolutely disgusted if you
Yeah,
ate
we
a
don't-
little crumb.
I should be a janitor. I can clean up a lot of
You should.
things. Let's.
Sometimes things are not cleaned up. Okay, here we go. So number one, you immediately notice that they have what? They have logs, right? So this is a logarithmic equation. So remember we have two types. Log equals log, log equals a number. Which one is it? So we drop the logs, right? So what are we left with on the left side? And what are we left with on the right side of equals? So really the only mistake that you would make is just in the solving of the equation. So hopefully at this point you guys are pretty good at this. Remember, I like to get my variables together first, right? So which one am I gonna move, 9x or x? I'd rather move the x, right? I subtract it. So 9x minus x equals, so 8x minus 4 equals 20. All right, so from here, we're just isolating x. We're getting x alone, right? So we move what first?
Plus.
We add that 4, what's 20 plus 4? And then finally we divide by 8, what's 24 divided by 8? So x equals 3, okay? Now, someone asked me in first period about extraneous solutions. And I don't know if there's any extraneous solutions in the quiz. I didn't work it out for that. I worked it out to make sure they worked out nicely or that they were, decent answers, but I didn't check to see if they were extraneous. Listen, the focus right now is not the extraneous solutions. It's whether you're doing the process correctly to solve the problem. So that's what my focus is going to be when grading. If you find one that's extraneous, that's great, okay? But my focus is that you're solving these correct, okay?
That'd be extra credit if you find it.
Maybe, if there is one. I don't even know if there is one. But if you do find one that is, then maybe I will give you credit for it, yeah? All right, so number 2. Is it logarithmic or exponential? Nope. Because what do you see glaringly? You see a big old log, right? Log. So that tells me it's what kind? It's logarithmic. Now, is it log equals log or log equals a number?
Log equals a number.
Okay, it's log equals a number, so Deanna, that may be what you mean. We're going to solve this by what? Writing it as an exponent. Remember, the base of your log becomes the base of your exponent. So 4 to what power? 4 to the 3rd power equals what? Not all at once, please. I couldn't hear you all over each other. 5m plus 9. All right. Now, what is 4 cubed? 4 times 4 times 4. So 64 equals 5m plus 9. So now all of a sudden you got a pretty easy problem to solve, right? What do we do first to isolate or to get m alone? So what is 64 minus 9? So 55 equals 5m. Last? Divide by 5. What's 55 divided by 5?
11.
So m equals 11. Questions about that? All right. Number 3. Is this logarithmic or exponential? Definitely exponential. Look, you have no log, but more specifically, you have a variable in what position? Exponent, right? So what's the base of that exponent? So my focus right now is I got to get that 9 to the m minus 6 alone, right? So is there something over here that we need to move away from it? We subtract that 4. If I subtract that 4, I've done it, okay? I've got 9 to the m minus 6 alone, and that equals 78. Now listen, there are 2 methods of solving exponential equations, but because of how easy what we did yesterday was, that's really the only one you think about. Now in this particular case, I wouldn't be able to do the first method. I can't make 9 and 78 have the same base. It's impossible. So that's why you guys probably will like doing the second method we learned better, because you know it works. It will work. So how do we do it? We rewrite this exponential equation as a log. The base of your exponent, 9, becomes the base of your log. And then we just loop, right? Log base 9 of what? 78 equals what?
10 minus 6.
And that's why this is so easy, because it just does the same thing every time, right? So what is log base 9 of 78? So we got 1.98. And remember, we're not going to round to 2, are we? So 1.98 equals m minus 6. Last step. So 1.98 plus 6 is 7.98. Yep. Is that what you got?
Yep.
What happened? You rounded to 2?
No, I just put 7.9.
A little fast rounding there. I mean, 0.08 off. That's pretty far.
Well, you got that wrong.
No, I wouldn't. If you did all the work right, I would not. Okay, I'm gonna do 4, but skip 5. Okay, for one main reason. I'll tell you. Let me do this one first, and then you'll understand. I think this one is it log or exponential?
Log.
Definitely log. You see log. Is it log equals log or log equals number? So we're going to drop off the logs. So m squared minus 12 equals m. Now this problem's a little different. You have one of these on your quiz tomorrow, or that I'm giving you today, okay? One. That's why we're skipping number 5, because it's another method. The one on the quiz looks like this one. This one has one real trick to it, besides the fact that you have to factor it. It's when I bring that m over by subtracting, where do I have to plug it in?
In the middle.
You got to put it in the middle, and that's really the trick. It won't go with the m squared, and it won't go with the 12, so we plug it into the middle. That way, it's in standard form, and we can now go through the process of factoring, okay? So that's really the only trick to that problem, and I'm telling you, the one on the quiz is just like it. It just changes some numbers. So we're going to factor this now. What times what gives me m squared? What multiplies to get a negative? All right, so we know, again, like all those ones that we've already done, they're working against each other, and they're working against each other to give me what is that number in the middle understood to be.
1.
So we got to find the two numbers that multiply to get 12, but have a difference of 1. What is that?
12 and 1.
No, 12 and 1 have a difference of 11.
6 and
4 and 3.
6 and 2 have a difference of 4. It's got to be 4 times 3. 4 and 3 multiply to get 12. 4 and 3 have a difference of 1. So that's the ones that work here, okay? So my last thing, with 4 and 3, which sign wins?
Negative.
So negative has to go with my bigger factor. Which one's bigger, 4 or 3? So it's got to be minus 4 and plus 3. Does everybody understand that? It's very important that you understand that. Now, last, we take those two factors, do what with them? So when I take m plus 3 and set it equals 0, what do I do to solve it? So it will be negative 3. And when I take m minus 4 and set it equal to 0 and solve it, what will m equal?
4.
Positive 4. Okay? So there you have it. M equals negative 3, m equals positive 4. Okay, now I'm skipping number 5 because of time. We're a little short on time. If we have a time to get back to that, I will. But right now, let's move on to number 6 because you don't really have one that looks just like 5 on the quiz. Okay? Exponential or logarithmic? Definitely. You have an exponent that has a variable, and what's its base? Well, what just happened here? I don't know. 3 is its base. So that's my focus, right? I want to do what with that 3 to the n minus 1?
Get it alone.
I want to get it alone. I want to isolate it. So what needs to be moved away from it?
Negative 21.
The negative 21 needs to go first, right? How? Add 21. So we're left with 8 times 3 to the n minus 1 equals, what's 51 plus 21? 72. And then we got to still get rid of what? Got to get rid of the 8. So we divide by 8. So 3 to the n minus 1 will equal 9. Okay, now I want to pause real quick, and I want you guys to understand something. I actually could do this one using either method. Y'all notice? Could I change 9 to have a base of 3? I could, right? So I could absolutely at this point rewrite this where it's 3 squared and they have the same base, right? If I wanted to, I could. Now these bases will drop and n minus 1 will equal 2, correct? Now, most likely, you guys are now in the mindset of rewriting it as a logarithm. So I just want to prove this to you. Watch this. If you would say, hey, the base of my exponent is 3, so log base 3 of what? 9 equals what? N minus 1. Now watch this. Go to your calculator and do log base 3 of 9. And tell me what you get. So 2 equals n minus 1. Notice anything? They're exactly the same. Look, they're exactly the same. So I don't care. If it's possible, if you do that method, that's fine. But most people are going to use this method. Why? It always works. Yes?
Are you gonna have any problems where you have to do it like a specific way, where they're all just gonna be whatever you, like what your preference is?
For exponential equations?
Yeah.
Yes, it'll be your preference. Okay? I won't say you have to do it this way. No, for sure not. So this one, either way, you add 1, so n equals 3. Okay? Just want you to be aware of that, all right? Again, the reason that most people kind of leave this method behind is because that method doesn't always work. Okay? Now, sometimes it's already written in that form, and when it's already written in that form, people think, oh, that's probably the easier way to do it. And that's why they do it. But most of the time, if it's not written in that form, they go with the logarithm. Okay? All right, let's keep cruising along here to the back. Very similar to that problem, right? You've got an exponent that has a variable, and its base is what? 18. So we got to isolate that. 18 to the 10r minus 3. So what's the first thing I need to move? Hello? I need to add that 1. So 73 plus 1, 74. Now what? Divided by 2. So 74 divided by 2 is? Alright, so we've isolated it. Again, if you look at this problem, if you try to go old school and say, hey, let's make the bases the same. Nope, can't. You can't make 18 have a different base, okay? And you certainly can't make 37 have a different base. So you're left with the only option. Rewrite it as the base of my exponent, 18, becomes the base of my log. So log base 18 of what? Equals what? All right. So hopefully now y'all are rolling. So we alpha window number 5, log base 18 of 37 equals, looks like it rounds nicely to 1.25. Again, I'm not going to get too worked up about your rounding. Just don't round to whole numbers unless that's your only choice. And you'll know what I mean by that. Like if it's 1.99973, when you round that, it's going to naturally round up to a whole number. But if it can round, like this one, to 1.25, that's perfect. Okay, so what do I do next? Add 3. So that's 4.25 equals 10r. And then finally, we divide, and you could, I guess, technically round this to 0.43, but I just went ahead and did 0.425 because it terminated. It was nice. I left it, okay? Again, if you put 0.43 here or 0.42 here, you think I'd mark it wrong?
Yep.
No. Okay? I'm not going to do that. You guys, you really think I would? You're just being a punk. Okay. All right. Let's go to number 8. Y'all definitely have one in your quiz that's like this, for sure. It's kind of like number 5, except number 5, you had to factor it once you did it, and I only put one factoring on your quiz, and it's more like number 4. That's why I skipped number 5, no problem. Is this log or exponential? You definitely see log, it's log. Is it log equals log or log equals a number? So we're going to exponentiate it. write it as an exponent. So the base of my log, 36, becomes the base of my exponent. So 36 to what power? 1/2 equals what?
20 minus 40.
And that's how you do it, guys, okay? Can't keep reiterating this enough. It's the same process every time. Now, what is 36 to the 1/2 power? So 6 equals 20 minus 4p. So the only mistake people make is just in the process here of solving. I got to subtract 20. What's 6 minus 20? Negative 14. And then the second mistake people sometimes make is, what comes down with that 4p? It's got to be negative 4p. The sign in front follows it. So we divide by negative 4. So negative 14 divided by negative 4 will cancel the negatives and become a positive 3.5. So there's number 8, positive 3.5. So those examples should be enough to really get you in a good spot as far as on the quiz. There's only 6 in the quiz where you have to solve. So the last things we're going to stop with, or we're going to finish with, is the graphing. So let's go over here, and I want to just remind you guys before we even start going to the specifics of the graphing. Remember when I showed you that day the difference between exponentials and logarithmic functions when you graph them? And I was talking about how like an exponential function has a horizontal asymptote where the logarithmic has a vertical. And I said, like for example here, number 9 is definitely exponential, right? So I said that the vertical shift is what affects that asymptote, right? That horizontal asymptote gets shifted. So like this one, since that's a vertical shift, it's going to do what? Now remember, on the outside, it is what it is. So this thing's going to go down here to negative 4. And there's that invisible line that we call the asymptote. And it's where? It's at y equals negative 4. Remember that? But with this logarithmic one, I said it's not a horizontal asymptote. It's a vertical one. So it's not affected by the vertical shift. It's affected by the what? Horizontal shift. And doesn't the horizontal shift happen inside? But what's the rule with inside? If it looks like x plus 6, it's actually a negative 6 horizontal shift. So it goes over here to negative 1, 2, 3, 4, 5, 6. So this thing is a vertical line that this thing cannot cross. It's a vertical asymptote. So we don't name it y equals, we call it x equals negative 6 in this case. So do y'all remember the difference there between those graphs? Okay, so now let's go to the specifics. All right, let's go to our exponential function. Again, you have a graphing calculator on your Chromebook, your school issue Chromebook, but also you have Desmos or apps on your calculator. Somebody somewhere find a way to do these if you don't have your Chromebook with you. Okay, you should though. Should have. Okay, so here we go. We've got 2 raised to the x plus 3 in the exponent spot, and then minus 4. And sure enough, graph it. Did it come down 4? Look, does it cross that imaginary line? No, we were right. Negative 4. Negative 4 is that asymptote. All right, so let's get some nice points. Don't just randomly graph it. Get some nice points to graph. So we got negative 3, negative 3. We've got negative 2, negative 2. We've got negative 1, 0. We've got 0, 4, which is an important one. What's 0, 4 represent? The y-intercept. So let's go back now and graph it on our paper. Ready? What are my rules? I got to go through my points, obviously. But what's my other rule? You can't cross the asymptote. That's a rule. So draw your graph where it goes through your points, but it never crosses your asymptote. So perfect. There it is. So let's talk about this. What was the domain for all exponential functions? Was it limited to the left and right? No. Negative infinity to positive infinity. Every time. But because your range is a horizontal asymptote, it can't go past that. So what is that limit that it can't go past? It can't go past -4, but it can go up forever. So from -4 to infinity. Also, while we're on it, the y-intercept we just called what? 0, 4. All right, so last thing that people sometimes really struggle with is in behavior. Look, as x is going to the right, y'all see my mouse? As x is going to the right, what's y doing? It's going up, up, up forever. Positive infinity. But look, as x is going off to the left, is y going down, down, down forever?
No.
No, it's approaching your what? And your asymptote is? So there are all of my key characteristics of a exponential function. Okay? Last, and I know we're about to run out of time, this graph here, I'm going to go to my calculator, y equals, we're going to go to alpha window number 5 and do log base 3, inside your parentheses x plus 6, and then outside your parentheses -1. So when I graph that, sure enough, it comes over to that asymptote we talked about. So let's pick a couple of nice points. You got -5, -1. You've got -3, 0, which is nice. And you've got 3, 1, which is nice. So go back to your graph, and here's what we got. We got a nice logarithmic function that does not cross the asymptote, comes up, goes through our points as it goes off to the right. So real quickly, our domain. Is our domain unlimited? No, that asymptote stops it going left. At what value? So it stops it at -6, but it goes to the right forever. The range is the one that's what? Unlimited. And then finally, our x-intercept here was where it crossed the x-axis at -3, 0. So there you have it. Anybody have any questions about that? All right, let me hand you your quiz, and you're going to be, I think, pleasantly surprised with how it is very similar to your review. This is due when you come back to school on Monday. If you, by chance, finish it today and you want to get it out of your hair where you don't have to think about it, you are welcome to bring it by anytime today. Either put it in the folder or in my hand, okay? Yes. Yes, we are. We're going to pick a day where we can do quiz question about this and that. Hopefully we'll have many for this. But, yes, we are definitely going to do that early next week. Early. So if I get these on Monday, we might even do it on Tuesday. All right. Do good on it, guys. I expect big things. But you know what I also expect? That you do your own work. Don't cheat.